Now that brings us to the problems at the bottom of the page. And read over the directions with me. For all of these problems, we have to complete the reasoning statement. If the triangles are not congruent in the statement, we're going to write not congruent. If the figure has an included side or angle, we have to label that included angle or side. And we have to complete the statement. So let's take a look at this first one. We've got triangles ABC and then the triangle to the right of it, and the statement should be ABC is congruent to. Well, first of all, let's look at these two triangles. Can we say that they are congruent? Do we have either of the three congruent criteria? The angle, side, or side, side? Well, the reason is side, side, and we can say that they are congruent. Okay, they're not exactly in the right position, right? In other words, side BC corresponds to side XY. Side AB, with the single line through it, corresponds to XY with a single line through it, and AC corresponds to this side over here, XZ. So we do have three sides that correspond, and we can conclude they're congruent, but we have to be careful in how we label our triangle. So angle A, triangle ABC, we start with A. A is opposite the side with three lines. So we're going to have to see which angle in this triangle is opposite the side with three lines. That would be Z. Okay, so we're going to start with Z. Angle B, or vertex B, over here is opposite the side with two lines through it. And so we find the side with two lines through it, and the angle opposite to it was going to be Y. So Y corresponds to B. And finally, the angle left over is X. So we've got the statement triangle ABC is congruent to triangle ZYX. Okay, and that makes sense because A to B to C takes us through the 1 hatch mark to the 3 hatch mark to the 2 hatch mark, and ZYX takes us also from Z to Y is the 1 hatch mark, Y to X is the 3 hatch mark rather, going back to Z is the 2 hatch mark. So we traverse the same sequence of sides, and we've got corresponding angles correctly marked. Let's go on to number 16. What triangle are we talking about here? We've got one of the statements is referring to triangle ABC. That's this triangle on the left side of this figure, ABC. Okay, this triangle. Which triangle do you think this statement is trying to ask us to include to complete the statement? Well, it would be the triangle on the right side, the thing that looks like its mirror image over AC, right? So we've got a triangle ACD that maybe it's congruent to triangle ABC. Notice we've got another triangle in this drawing. We've got the entire figure is triangle ABD. But clearly ABD cannot be congruent to ABC because it's a different size, and one triangle fits within the other one, which can't happen if they're congruent. So we must be trying to prove ABC congruent to the triangle on the right, ADC, ACD. We haven't determined how to call it yet. So can we prove that? Well, do we have side, side, side? Do we have any way to prove that side AB is equal to side AD? No. So we can't use side, side, side. So let's make a little list of the things here. We've got side, 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 angle, side, and angle, side, angle. We've eliminated side, side, side. Let me redo this, angle, side, angle. Okay, so we've eliminated side, side, side. How about side, angle, side? Well, we've got side BC is congruent to side CD. We've got angle, this right angle, and a right angle over here, and we know right angles are all congruent. So we've got a side, we've got an angle. Do we have another side that's congruent between these two triangles? Actually, we do. AC. AC is a side that is shared by triangle ABC and is also shared by triangle ACD. they overlap on side AC. So remember that AC, the measure of AC, equals itself. So in terms of looking at these two triangles, AC equals AC. That's why earlier we reviewed the reflexive property. We're going to have to use the fact that AC is equal to itself. That would give us BC is congruent to CD. That would be one side. The included angle is a right angle, which is congruent to the other right angle, and AC is congruent to itself. Okay, what I can do is if I wanted to, I could kind of separate out these two triangles a little bit. Let's say that I could pry them apart like this. Okay, I'm kind of like cutting them along side AC and then moving them apart. What I have here is I have ABC, and what I have here is ACD. Of course, I really can't do these in reality. I can't separate this into two points A and 2 points C, but I'm doing this as an illustration so that you can visualize it a little bit better. And if we look at triangle ABC and triangle ACD, we will see that side BC is congruent to side CD, that the two right angles are congruent to each other. I could put a little dash between them to show that they're congruent. And side AC is congruent to side AC. Okay, so a side is congruent to itself. And therefore, although in reality they're sharing the same sides, we could visualize it as if we could separate these two triangles, and we could see then that we would have side, angle, side, and side, angle, side. So let's carefully conclude that our reason is side, angle, side, and the statement would be that ABC is congruent to. Well, we know it's ACD, but we don't know the correct order of the letters. So let's look at angle A. Okay, so in the first triangle, angle A is this angle here, and it's opposite the double marked side. Well, that would be the same thing as A in this triangle. It's also opposite the double marked side. So we would have A corresponding in this case to itself. B. So B is opposite the side AC, and so is D. Okay, so now we would have B corresponding to D, and that leaves C. And that makes perfect sense because C is the right angle for the left triangle, and it's also the right angle for the right triangle. So it is the corresponding side of each triangle. So our conclusion would be that because of side, angle, side, we can state that triangle ABC is congruent to triangle ADC. And those are the correct order for the letters.